Please join me in welcoming Chapo and Logic.
Hi, DEF CON. Can you hear me? Closer? I can't get closer.
How's everybody doing? Good time?
All right, so serious business here. What's up?
You'll have it in a minute. Yeah, in a minute.
All right, so no bio stuff. We're just going to get right into it. Going to get really off topic for like the first 20 minutes of it until we kind of gradually get on topic, mostly because I like talking about formal systems, so we'll get into philosophical digressions here. Although we are going to be talking about automated security tools and how we need automation, but if you rely on it too much, you can run into problems. But anyway, so on formal systems. This is a game I played a lot as a kid. It wasn't that it was challenging as a game, whereas other people, maybe they start with the challenge of it, but not us. You know, we could probably do this in a minute or less. What I was fascinated about as a kid is that half of the different permutations, or I guess combinations of this, are impossible. So in this case, if you guys have ever, and this is interactive, if you guys have ever tried to solve this, you know, in order, so you got to get that 1 all the way up there. I'm going to waste my time just to at least get the 1 up there. Okay, and the 2's close enough. Anyway, this is unsolvable if I wanted to get 1 through 15. But I could get 15 backwards, which you can't if you just buy one of these. Nothing else on that, I just find that really interesting. You're welcome. This is the same kind of concept. Show of hands, who thinks they know why you couldn't solve this just based on this picture? Yeah, cool. 2 blues. Yeah, there's every middle square is a unique square, and people that are familiar with Rubik's cubes, they know that the most important square is the middle one. That's the one that doesn't change, so to speak. I also find this interesting. This is a game that maybe you would never end up playing naturally, of chess. It starts kind of like this. It's a variation of chess. I think it's called Chess 960. You start all the pawns in the right place, but the back pieces you randomize, and the black and the white mirror the randomization. So you end up with a game like that. And all of these are kind of, these examples, I need to update. All these examples are kind of fitting the same theme of formal systems. We're not breaking the rules. We're either changing the environment or the starting positions. And these first 3 examples, we changed the starting positions. Here's a couple of examples of changing the environment. 3D, Qbert. And the point is, like, the first 2 were like, yeah, okay, you're being trolled with this impossible situation, but it doesn't have to be that way. Like in this instance, you might actually end up playing a very interesting and fun game of chess. This is another example of changing the environment. So some of you may have seen this video. There's this 23-minute video, and I'm only going to do a good, like, my favorite top hits, 50 seconds of it. But it's an impossible, well, not even impossible, it's just a very challenging Mario level that this guy plays and does really well at. But it's funny, it's a funny video just because of how ranty it is. Just look it up on YouTube, like type impossible Mario level, guy rants, whatever, you'll find it. But here's my favorite parts of it. I'll make it a little bit bigger. The level starts out that way. That's my favorite right there. Yeah, I would have audio, but I'd just splice so much of it together, it'd be all choppy with that. So just check it out on YouTube. It's hilarious. It's more hilarious than that. You are going to have to watch it. All right, so kind of changing gears here on wrecking the Earth with resonant frequencies. And I have a picture here with Tesla because, you know, the whole earthquake machine thing. I'm not going to get in detail with that. I'm just going to kind of skip along, sort of on that theme, though. Has anybody ever read this book? Awesome. Okay. It's by far my favorite book, and not even on a margin. My second favorite book would still be a tenth of how good I think this book is. And it's not about computers or hacking, but I would say I learned most of what I know strategically about hacking from this book. It's about formal systems. It's more than that, though. If you haven't heard of this book, check it out. At least read a preview on Amazon or whatever, but read this book. It's awesome. But about 100 pages deep into this book, the author, in between chapters, talks about this scenario of, and these illustrations are from a friend of mine, so it's not from the book, but there's a tortoise and a crab, and the crab is kind of the instigator here. He's giving the tortoise a record. Well, the record player, I should say, is supposed to be high fidelity, so high, not only very high fidelity, but it should be able to reproduce any sound. And I'm looking at this as our signature-based system. So the crab's trying to foil this, and he has a record that has a resonant frequency, either geared for the horn or the wood on the record player, but it has a resonant frequency that will cripple that record player and make it not work. So that's the black record there, and that happens. So to try to defeat that, you build kind of a more signature-based system that might detect those frequencies. So you have this red needle that is analyzing the record to try to avoid this. And you run into problems with that too, because say the record player detects the signature, so it decides not to play it. Well, now your record player that's high fidelity is not reproducing every sound. So you fail that way. Or say this is just an evasion technique, and the record still plays. And still destroys the record player like that. So another solution, and this is like just cat and mouse. This is not supposed to be specific, but another solution is like, okay, well, let's have several different horns. So when you give it a bad record, you can just switch to a different horn that can play that record. But again, you can have a record player with several different tracks and destroy all the horns. And then again, and that's kind of the theme. Every system, I wouldn't say is vulnerable necessarily to exploitation, but I don't think that there's any perfect system just because it does something. So it doesn't have to be exploitation. It could be some kind of denial of service. It could just be doing something that it's not meant to do, which may not be damaging, but it's still not a perfect system because it's doing something that it wasn't designed to do. So now we're going to get into some more lower tech, kind of more familiar abuses, and I'm going to hand it off to Ruben here.
So we're all very familiar with this picture here. I mean, trying SQL injection, so when somebody enters it into a database, it drops, or SQL injection attack, typical. But in these cases here, it was more or less, it's not signature-based, but it's still abusing a system in an odd kind of way. That's why it's oddities. So this guy here, Robert, he he wanted the special license plate. He was really into sailing and boating and all this great stuff. And he wrote down, the first license plate I want, I want it to say sailing. If I can't get that, I want it to say boating, And if I can't get that, then I wanted to, eventually just say, what was it?
No plate.
No plate, that's right. So he wrote down no plate. So what happens is, obviously the first two were taken, and he got a plate that said no plate. Well, with that, eventually he ended up getting 2,500 notices in the mail of violations and tickets, because every time the cop would write no plate on the form, yeah, exactly. You can see where this is going. So he got all these violations. So next slide here. Same thing with this. So in the first slide there, it stated they've switched over to none and missing. And this guy, the same issue happened. I mean, he had a plate that said missing, and he got violations as well. This guy here, he thought it'd be cute to have his little motorcycle, I believe it was, to say no tag, and brilliant. And when license plates had no tag on them, the cops would write down no tag, and his actually showed up with the 200 violations. So when he got his license plate in the mail, those violations were there already. The same thing with this guy, it's void. The unknown. And then this guy here, I guess his favorite number was 7, and they called him Racer X, Racer X, and he ended up getting $19,000 worth of fines. And his quote out of this article was, he thought he messed up the system so bad that they were going to send him to jail or something for doing this. So this is just kind of a unique way of showing, when, I guess, we're kind of analyzing or not paying attention to specifics in certain systems, you could really mess things up, So go ahead and go next one. Who's familiar with these? And we all know what they do, right?
We're from Arizona, so we're really familiar
Yeah,
with
so who
these.
still has them in their state is the question. I know they were trying to, okay. So we are very familiar with these, the speeding tickets. Now, a while back, I think it was in Maryland, these students thought it'd be real neat. They graduated from elementary school, and they hated their teachers, right? I mean, who hated teachers? So they would actually photocopy their old teacher's license plate and run through the speeding ticket cameras, and those tickets would actually go to their teachers. I mean, there was no validation of who was actually driving the car, and it says pimping because that's what they coined the term. It's, I don't know, pimping ain't easy or something. I don't know what they were thinking, but that's how this, I mean, there was no validation, from this whole attack, if you will. So Pirate Eye, does anybody know what Pirate Eye is or heard of it or?
It's a little obscure.
Okay, so Pirate Eye, well, first of all, they claim to be the leader in anti-piracy. You want to go ahead and show the next slides here, or yeah.
They're the leader in some other stuff, apparently.
Yeah. they really, could use a web admin or something. WordPress, it's pretty obvious probably how the attack went down. But anyway, Pirate Eye, what they do is, as I said, anti-piracy in movie theaters. This story came about because some guy was wearing Google glasses within a theater watching a movie one night. And when he was watching that movie, I guess, he ended up getting escorted by, three-letter agency or something. But what this service does is pretty much they put a little camera, if you will, mount it at the top of the theater. And once the movie starts, it actually starts recording. And their services, it kind of works like a SOC, a Security Operations Center. And so they're constantly, that device is constantly scanning 3 seats at a time for, any recordable devices, camera phones, anything like that. And it got triggered, his Google Glasses got triggered by this. So what happens is once it does detect, something that possibly might be recording, they send off a text message or an email to their point of contact at that certain movie theater. And they say, hey, this guy was recording in your theater, and then eventually, they try to get the guy arrested or whatever. So to attack against that, just abusing their systems a little bit and how you could, I guess, yeah, just basically abusing and attacking them. Logic here came up with Spider Eye, and spider because I guess it looks like spiders, spider's eye. But he actually
and so can you.
Yeah, go ahead.
Oh no. Well, okay. Yeah. So this is my Thingiverse profile. I only have a couple things on there, but this is a iPhone case, and I don't even know if it'll fit an iPhone. That's not the point. But I made it so it fit the 100 lens or 50 lenses that I purchased, but it's OpenSCAD format, so you can just change that one global variable and put a different lens in there. But so it's an iPhone case that you put a little lens in, so it's kind of plausible, it looks like it might be something that you're recording with. So the idea of that is you go into a theater, put the iPhone case in the cup holder, there's a chair, that's the theater.
And I told Logic, I said it'd be nice to get mannequins to make it look like real people, we just have a bunch of, but it'd be nice.
All right, so I'm going to take this a little bit here. Barcodes, I've done barcodes or stupid shenanigans with barcodes for quite a while, but I really don't like VIP cards and what they stand for. And they're used for a lot more than what they were originally intended for in bad ways. I think the main reason that they first started, you got a thing called correlated goods. So you got hot dogs and buns, right? If you're a grocery store retailer, you can have a sale on hot dogs, but then jack up the price of buns. So then people are still paying either equal or more than they expected to. But that's obvious. People would catch on. Hot dogs and buns, you might notice that the buns cost more and you'd catch on to that. So you need to use statistics to find less obvious correlated goods. Correlation in statistics, that's just the right tool for the job. So one of the best ways to do that is give everybody a discount card, a savers card, but it's really just data mining for those statistics. So one thing that came out of that, and I think I learned it from my useless MBA, it's like in marketing or something like that. It was wine and diapers was a significant correlated good for some reason. And it's funny, but that's the point. It's not obvious, right? So that was the initial reason, and whatever, that's sort of evil, but it's kind of the Diet Coke of evil a little bit. So that's their solution to that. But kind of privacy things. So you can figure out shopping preferences a little bit, your hobbies, your clothing size, which even could say a little bit about health as well. But then, smoking, alcohol, whatever, pills, pharma stuff. They'll know if you own a pet. And I was going to say birth control purchasing, but there was also the case of not even birth control purchasing, but even like just correlated things that would indicate you're pregnant. There was a big story about that. And then health insurance claims. I forget the name of the program. I think, it's called SmartMouth. I don't know if they're still doing it, but HSAs would buy this data right up, and you might get a claim denied because of your Saver card. Things like ice cream means you're obese to a health insurance agency. Cardiovascular disease, that's homogenized milk and meat, and cancer, additives, chemical sweeteners, and all that, which may or may not be the case, but to them it is. Law enforcement, I think, has been known to use it too, but this case specifically I find interesting. It actually didn't get used in court, but they tried to. So Vons, which I think is a subsidiary of Safeway, they had a yogurt spill in the aisle. Somebody slipped on it, fell, was hospitalized for about 10 days. And then tried to sue to recoup some of his losses, which I don't really care about the politics of that. I mean, he's probably in the right for doing that, but that's not the point. Vons was trying to data mine his VIP card to try to see how much alcohol he was purchasing to try to build a case against him. They didn't end up using that in court, and my theory on that is that would be showing their hand. The store, if they started doing that, that would set a precedent that stores would do that, and people might be more skeptical about the cards. But
yeah, so one point to that as well, not just with these special shoppers cards, but nowadays also they're also tracking by debit, credit card, and all good stuff. I mean, they'll print out certain receipts or something that you've bought in the past for something, and you're just like, wait a minute, how'd they know that? I purchased it. Well, obviously it's tracking it. So just another good point.
And we have one giveaway item. We don't have enough for everybody, but there's maybe about 100 of these in the box we have up here. So after the talk, come up and take them if they're here. But this is my VIP card. It ends in the digits 2600, 2600. And the 0 is the checksum, and it does work. This does work at Safeway. This also works at our local chain in Phoenix, Fry's, Kroger. It might work at other places too. But the point is we all have the same barcode. And that's funny. When they're data mining, we're one very large customer.
So you better fight for those gas points, because whoever gets to it first is the person that's getting it.
And on my same Thingiverse profile that I was talking about earlier, and you can just Google Thingiverse and my handle, XLogicX, or whatever. But I have a list. I have on this site, I have a barcode generator. So if you want to 3D print, laser cut, whatever. And I also have a list of valid barcodes that I'm currently using. So if you know of a barcode for a store I don't have, give me I don't need your whole VIP card, just the first 6 digits, and then I have a Perl script to generate the rest and make it end in 2600. But here's some examples. Like I did a laser cut barcode. It totally works. You got to put it on a black background though, because I actually cut the spaces. So what comes through is the lines from the black. This doesn't work anymore, but it's on my cell phone right now. Some of the lines have fell off. So it's kind of gimmicky. It doesn't work, whatever. But it did work for the first few weeks, so that was kind of fun. That's just from a vinyl cutter or plotter or whatever. You don't have to be as fancy as that, though. I just thought the gimmicks were fun. But there's smartphone apps that you can download. I listed 4 of them here. I think they're the most popular ones. Just make sure to select UPCA for the barcode you're using. I know some phones don't scan, but I think most do, just because of the type of screen. Or just print it on a piece of paper. The point is, use our barcode that I have listed on the Thingiverse site. So even if you don't get one of these, you can still use the barcode. And then the last point, what if the store blacklists it? I don't care. It'd be funny if they did. It would show that we pissed them off enough to make that kind of a difference at least. But still, I got the Perl script, so just get somebody else's first 6 digits and just generate off another one. And there's the central repository of my barcodes that we all can use. So now we're going to get a little bit more technical. I'm going to go through the first 2. There's like 3 subsets of things I'm going to go through. Forensics, AV, and IDS. IDS is my favorite, so I'm going to try to spend the most time on that, which means I'm going to kind of blaze through a little bit of the forensic and AV stuff, and then we'll try to do the most live demo proof of concept stuff for the IDS. So first with forensic stuff. Anybody familiar with Scalpel? Show of hands. Scalpel, okay. It carves through a file system for files based off of, they say magic numbers, but it's mostly just the headers and footers part of it. Because like magic numbers in Linux, it's more than just headers and footers. There's regular expressions and everything. I've looked through the .h file. But in this case, it's headers and footers, and also like optionally how far into the file you want to go. So we're going to troll that a little bit. This is just like a loose graphical example of what a file might sort of look like on a file system. It's actually kind of horrible, but here the green is a hex dump of that, of just a simple HTML page, and then like you'll have metadata, but that's not part of the file itself, it's somewhere else. So this is the same HTML file. This is a busy slide, I'll zoom around, but in the middle here is kind of what a Scalpel signature may look like for an HTML file. So the first part is just the extension title. The next part is whether it's case sensitive. This number is how many bytes to carve into if you don't have a footer. So we'll stop at that point because some signatures don't have a footer. And then the header and the footer. So if we go down here, this is how it would carve. It sees the HTML, starts carving the content, and once it hits the HTML closing bar, it knows to stop and just carves the whole thing out and spits out a serialized HTML file. So that's how that works. So thinking about how that works, what do you think that might do if that was the contents of a file? Like, it's actually horrible. It's really, really bad, and we'll get into that. It recursively, like, it'll go to the first HTML. I'm pointing at my screen right now. That's but it goes to the first HTML, and then it'll carve down to this, and all these HTMLs will be content. And then it'll start at that HTML again and go to that one. And just keeps going. And then it'll start at the next HTML start, and it's bad. So I could do a live demo, but for time I won't. But I did record a demo I did. The tool I wrote, it's in Perl, it's called Magic Bomb. So I'm just showing my directory here real quick. I'm running my tool Magic Bomb. I'm doing a multiplier of 50, which means 50 of every definition in Scalpel, generated a payload. And then I'm going to show us what we have as a result, our payload, just to show you how large the payload size is. For some reason, okay. So in this case, it's 17K. We're going to run Scalpel against it, output directory out. So you see it says like 50 of each file, because that's what I told the payload to do in our 17K payload. Now I'm running DU on the output file. That just gives us the actual output that it spit out. This is 17 megabytes. And keep in mind, none of the files that it carved out were actual files. They're all false positives. I'm also demonstrating the audit text file that it puts out. It shows all the file sizes of each file. What it doesn't give is a total, which kind of sucks. So in that case, I kind of just wrote a little hack Perl script, which you're seeing right there, to parse out and add up all the different individual file sizes. I know it's kind of lame to show code in a presentation, but it's like almost a 10-liner, so whatever.
Go on.
Howdy. Yeah, this thing, it can do itself.
What?
No, so so I did the Perl script against audit.txt, and it's close, 16.7 megs as opposed to 17 flat. I'm only demonstrating that because I'm about to do a really massive payload that I couldn't practically do. So I can do a Scalpel and just say, just give me the audit. Don't carve, just tell me what it would look like if you carved. And then I can run my Perl script on it to show how damaging it would be had we ran the script that way. So that's what we're doing. I'm creating a payload of 30,000 of each file, and it's reading from a scalpel.conf file, and that's how that's going. This is actually looking like it's going slow. In real life, it goes slower because you see it finish in 90 seconds. That's what it said. So the payload is 10 megs.
May I have your attention, please?
Pause.
Keep your arms and legs in the car at all times. If you're a new speaker, raise your hand.
Doesn't matter.
Well, yes, it does.
No, it really doesn't. No, that ain't happening. Who wants this?
Yeah, so
I'm too fucking edge for this shit, man. I'm not doing that.
so you said you wanted it here. You come and get it if you want.
Should I do his for him?
Second, yes, you should.
All right, I'll do his for him.
speakers do a fucking shot. Shit's vodka, I got him.
Cheers.
Thank you, gentlemen. Continue.
All right, continuing on. So we're carving 30,000 of each file. Running the Perl script on the audit.txt. And I'll zoom into this astronomical number that it's eventually going to show. So we have a 10 megabyte payload. That's 3.7 terabytes. And it actually takes like hours to actually, it would take a long time to carve that if you have the drive for it. So, we get to the point, kind of. A 17K payload, the first thing we did, that's a lot of files that it carves out. It might DOS your brain if you're trying to analyze it. 10.3 megabyte payload, so a lot that it carves out, 3.7 terabytes. That might DOS your drive. If we did a 100 megabyte payload, that would just DOS Scalpel. Scalpel would just break. Unless you have like a supercomputer or whatever, okay, a gig payload, whatever, you know. So that's funny to me, all that. So AV trolling, I'm not even really going to go into this tool that I wrote a little while ago. It's called HivSneeze. What it does is it just reads a ClamAV signature file and then spits out a file for each signature. So then if you were to run ClamAV or a lot of other vendors on it, it's going to look like a bunch of viruses. And the funny irony is none of them are actually viruses. They're all false positives. This is a way to troll. But a more interesting kind of thing, this is, and the highlighting is a little bit off. It's really supposed to be this highlighting this first byte here. But it's what I call a tumor. And we'll get into how this works. And it only really plays off of one individual vendor. But so say our virus signature was this binary here, which is actually in ASCII just the letter X. This red stuff here says expect us. So this particular vendor, the way it quarantines is it takes the metadata, makes a file out of it, takes the virus, makes a file out of it, XORs both files with the key of 6A, and then puts them both into one 7-zip archive container. So you have, you're left with the you're left with the 7-zip file, and both of those metadata and virus files are in there, XORed with the key of 6A. The idea is to neutralize it so it doesn't rescan again, because if you have a virus in its own quarantine file, an actual virus, it will detect it. And we're using that. So before I get into that, I know some of you might know about the ever so powerful double XOR. We're using that too. So here's the process. We got, okay. We got our metadata, a file type, not a tumor. We got our tumor, and say the virus signature is this string of bytes, which I highlighted in purple here. And then the file, it's like a 2-byte file, but this next string of bytes is not that signature. And just to like cut to the chase, you'll see it. But this here, if you XOR it with 6A, would be the virus signature. So we quarantine it, and that's kind of what it would look like now. So it's still a virus, or to the AV vendor. So you XOR it again because it's still a virus, and it just keeps on building up with metadata. So let's see that. And this one's a little bit longer because I kind of hate magic. I don't want to show you an awesome, like any kind of tool that's just doing it all for you. HivSneeze will do this for you, but I'm not going to do that. So I'm going to manually rip a signature out of ClamAV, XOR it manually, combine it manually, and show you what the vendor does to it. So I'm copying ClamAV's main.cvd file just to a local directory here, my tumor directory. I'm using DD to chop off the first 512 bytes because main.cvd is actually a tar file, but not the first 512 bytes. So I'm chopping that off, I'm untarring it, And then I'm going to have to edit the permissions. And I don't know why my video is stopping at like the 20 seconds into it each time. Okay, here we go. So now we have our main.db file. Fix the permissions. Show you what the actual file looks like in the raw. And I scroll down here to show some more meaningful names because the first ones are all hexy. So yeah. So now that we see that we have plain text signatures, now we can get our hands dirty and play with them. So I'm grepping for a signature that's very tumorable. It's a Alba IRC worm. I guess I didn't need to grep it again, but that's what I did in this demo. And so the format is the virus signature name, an equal sign, and then what follows it, that hex that you see there, is the signature itself. It's just ASCII hex. So we're just going to use the tool XXD to make an actual binary file. So now we have what would be scanned as a virus if we were to scan for it. And then I'm going to cat it out. So you can see it's kind of plain text. It looks like a script. That's the hex dump of it. This is a Perl one-liner to convert it, XOR encode it. Trivial, but I'm using the key of J. J in ASCII hex is 6A, so that's why I'm using J. And I'm just showing side by side. There's the XORed one and the original one. And then I'm just going to cat them both together, and that will be a real payload. That will work. Tumor.txt. And there it is all together. Like, I really like seeing all the intermediate steps. There's no magic here. Copying it to a shared folder, because in this demo this was a Mint VM. So then we're going to go over to a Windows VM. Sorry about how grainy this is, but I'm copying the text file over to the desktop, and then this is the quarantine folder, so a file pops in. I didn't mention what vendor this is, but if you know what .bup means, you know what vendor this is. So note that it's 3K. And I'm going to try to access the file. So that would be considered an on-access scan. So I'm going to open it with Notepad++ and malware. Found it in quarantine. And then you'll also notice that it's 6K now.
Tumor.
Tumor, it grows slowly. We're going to access it again. Oh, crap, there's 2. And now it's 8K. So I would say that this tumor, thankfully, is benign. It doesn't repeat forever. I didn't weaponize it because I don't care. I like formal systems. I like abusing formal systems, and I stopped there. Now, our favorite part.
All right, so getting into a little bit of IDS fun. You skip that slide.
Okay, yeah, well, this is like the demo stuff, so
yeah,
let's go to our, this is Snorby, just a fun.
So our IDS system here, and which one is it there?
Oh, it's this guy here.
Yeah.
I should probably zoom into this.
So basically, we see what's going on here is typical, you know, in a typical SOC or a situation here, I guess a little bit of a story. You know, you always have analysts that are sitting on a channel just watching the SIM or something, or IDS or whatever it may be, in this case an IDS. And a lot of times, especially nowadays, you know, it seems like training is always a hard thing to, you know, come by with training people up in order to analyze these kind of events and signatures and what everything means. But clearly here you could see, you know, it looks like a possible SQL injection attack. And when I see these things, and I've even had, you know, people do this in real life, You know, they would take this and be like, okay, you know, I see they're trying to attack our server here. Let me try to go ahead and validate that and see if it is actually, you know, possible to, you know, SQL injection on this thing.
And before we get to that, just notice this is a rule. I want you guys to see this is a rule. This is what it looks like, what it's detecting. It's pretty simple. It's just looking for, I mean, there's a little bit of like, yeah, not case sensitive, has to be in the URI, but really it's looking for the word select and version. So somebody could actually just Google for something, and maybe in the URI it'll say like, well, I want to select the version of some software thing. It's going to look like a SQL injection. So this is, in that scenario, you could have somebody that might think, okay, well, maybe my site doesn't even use a SQL backend, so let's just put it in the URI bar and see what happens.
Now, a smart analyst would probably just, you know, take that first piece where, you know, the SQL part was. But, you know, in some other cases, I have seen this as well, which is going to demonstrate here.
I just wanted to show some of the stupidness of that. Okay.
So the analyst is thinking, well, I'm going to, you know, verify this and post this, you know, to our server.
And notice, you know, in the URI, you got the union select, you got some obscure stuff. We don't know what that is, so that's what we're testing. So let's test it. It's not SQL injection. So it's, again, just playing with signatures. That's all it is. It's not like elite hack. And so with cross-site scripting, usually your attack vector, or maybe your attack vector might be an email or something like that. This is obscure as hell. The attack vector is a security analyst that is watching an IDS.
That's right.
That's our attack vector. So next is a script called 8Ball.
With the rocket.
Yeah, this slide. Sometimes you got to kick the tires of your IDS with a rocket launcher. So it's not the first tool like this. There was some tools that I sort of researched, but I couldn't get the actual code for it. It might be Vapor, but Stick and Snot, those are some big ones. This does a little bit more, and it's released, so you don't have to hunt for it either. It's kind of like, this is a very, it's bigger than this, but like testmyids.com, if you go there, it's not even HTML, it just has this text here, and it plays off of this signature. It's meant to test your IDS, as it says, to validate that it's working. And that's what this tool is doing to 8Ball. I mean, I even added throttling to it, so you can actually make it slow enough to where you're not dropping packets, and you can slowly increase it to see where your IDS starts dropping packets to test the performance of it. So we'll just kind of get into this a little bit more. Here's a slightly more complex rule. It's not the whole rule, it's just ... here. So unpacking a little bit, it's looking for awstats.pl. There's some regex in here, so it needs to have configure, update, plugin mode, or those, equal any amount of anything including nothing, and then any amount of alpha numeric text surrounded by pipes or system. So the question is, so could we just do that, a get for that, using netcat or whatever? And the answer is yes, we can. So it triggered that rule, and that was the packet. This isn't how the attack would actually work. We're just looking at the signature and going, well, it's gonna, if you just feed it that, it'll trigger. So what about automating it? And that's what 8Ball does. So it literally reads a rules file and generates a packet for all of the rules. So you run it, your IDS is going to light up with unique rules. Maybe not all of them because regex is hard to deal with backwards, but it does do the PCRE stuff too.
So it takes me back to my SOC days with the channel flood. I'm sure some of you are familiar with that. So.
And this I'm going to do live. I'm not going to do a video for this. I just have it just in case. So that's fine. This doesn't take too long. Here it goes. This is the script running. In green, you have the content matches. In red, you have the PCRE matches. So it's actually looking at a regex string, creating a string that would match that regex. It's regex porn. And just sends that all at the IDS. And while that's going, I got a couple more slides to go over because this takes like 2 to 3 minutes. So I want to make use of my time efficiently. Some tools that some things I haven't added to the script yet, but plan to. So the first thing, the UDP, you can do spoofing. So you can light up some of the TI stuff, or make it so it's not attributable as much. One of my favorite things, and it's like crazy to go over this in 30 seconds or less because it's a big, heavy topic, and I'd like to get into it more later in a different talk. But RDoS, regex denial of service. This is a bad regular expression. In this Perl script, there's only 2 lines here that really matter. I'm taking an input, and I'm seeing if that input matches that regular expression. So if I run it the first time, I say A's and a B. That took 1.5 seconds. If you add just a few more A's to that, that takes about 10 minutes to see if it matches. That's bad on IDS, that's bad on web apps if it's doing any kind of validation, but it also is taking advantage of somebody writing a really, really bad regular expression. So another thing is long circuiting. If you do any kind of coding, you know, if I have an expression that says if A and B and C and D and E, then fire the laser. So, you know, a compiler will be like, well, if A is false, the rest of the thing's false. Don't evaluate the rest. So the long circuit attack is make all of them true but E. So it doesn't match, but it takes as long as it possibly can to find that out. So if we look at a more complicated rule here, all this stuff in yellow is the stuff that it has to match, and then a regular expression down here. So we do all the stuff that it has to match, and the regular expression is just saying we need the range, colon, space, bytes equals, and then this is a character set, so 0 through 9 dash, space, comma. We need 100 of those is what that's saying. So I do 41, comma, 41, comma, 41. 99 of those, and an X. So it's going to like really hurt the performance, but it's also not going to trigger an alert. And that's funny. So some other stuff, just wrapping this up, we're kind of done. Well, actually, but let's see if that's done. Oh, we can do it in 2 minutes, we're good. It finished, so now I'm going to go to Snorby up here and just go back to the dashboard. That was actually just when I was testing it this morning. I ran the script twice. So I'm going to do force cache update. That will take about 1 minute. And so just to wrap it up, Yara is something that I'm interested in. I haven't done anything with it, but it would be same thing. Attention deficit disorder is also pretty awesome. It's not ours, but I guess it kind of poisons memory. And so if you run volatility, it's going to be a little bit nasty. And all your awesome tools. So probably don't have enough time for questions. I'll leave this up here for a moment. I'm going to kind of check to see if that's, maybe I'll just click on the sensors and see. There's 200,000 events in here right now. So if I click on it, I'm seeing 207,000 events up here. So it just triggered 7,000 events. And they're all unique. I could go to any one of these and analyze it. Like it just shot that at it. Because the rule is looking for just that, and that's what it does. So
That's it.
that's all.
Thank you.